Today I thought we'd try something a little different. Having recently done a video on Magic Eye tubes, this is a Magic Eye, I thought we could try and use the triode section of one of these as a radio. Now there's something a bit different. I know it's all been done before, but let's do it properly. Let's measure the emissions on a tester, let's check it out as a triode amplifier, and then let's finally make a radio. Initially what we're going to do is we're going to use the universal chassis simply as a holder for our Magic Eye tube. Here is the tester which we're going to use to test it with. This beast here is a 1950s cathode ray tube tester. Wow, you say. Works fine, and we'll be just using it to test the tube as a triode, which is great. So nothing much to say about it. It's a very simple thing. Let's turn him on because we've just connected up the wire going here to the universal chassis. So we give it a click. We're now on, and what we're waiting for is seeing the emissions test, which should prove that it actually works with any luck when it's heated up. Oh look, we have quite a good emission from the triode. All we'll do now is we'll simply check it for shorts and leakage, so the cathode leakage. Nothing there, we're just doing this really for the fun of it. Electrode shorts, the cathode, the grid, and the anode, so there's nothing wrong with that. It's back to the emissions again. Having just tested the triode in this Magic Eye here for functionality on the tester, let's see if we can just use that as an ordinary triode valve. All we need to do this experiment is an audio oscillator, an oscilloscope, and obviously the Magic Eye itself inside the universal chassis. Let's have a quick look at the circuit first of all. You probably can't find anything much simpler than this. Here we're just showing the triode part of the tube, and we're going to feed the oscillator in through a capacitor to the grid, which is on pin 5. There's a 1 meg resistor here. We tie the cathode straight to ground, no cathode resistors. We're doing this as easy as we can, very simple. And there's a 50k resistor here between the anode and the supply. The supply in this particular case with the universal chassis is about 95 volts, so it's not a great deal. And of course we're taking the output straight to the scope, which is from pin 3. First and foremost, let's check out the oscillator here. We're set on 1 kilohertz, that's 1 kilohertz sine wave, and we have 1 volt peak to peak. So if we look at the oscilloscope, which we've actually attached to the output of the oscillator without the unit being switched on, you'll find that we have here, it's on 0.3 volts per division, 1, 2, 3, around about 3 divisions there. Now if we change this thing over, this is now going to be connected up to the output. So if we change that now to 3 volts, so that's now set on 3 volts per division. If we now turn on the unit, let's wait and see what happens. Now we're looking at the output of the Magic Eye, or the triode part of it, should I say, and something's happening. Here we go. So that is actually the output of the oscillator. So remember, that's approximately 1 volt peak to peak. This is 3 volts per division, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's about 12 volts, so it's about a 12 times amplification on that. A reference is taking about 1 milliamp anode current there. Whilst we have this connected up, let's just change the frequency. That is 100 Hertz. Oops, there we go. It doesn't like locking at these very low frequencies. And 10 kilohertz, which is the response of this Y-amp does drop off a little bit. There we go. And so that's 10 kilohertz. Whilst I was originally going to build an example of the Magic Eye radio on the universal chassis, I found this up in the loft and thought, you know, I may as well try and use this while I'm at it. Note that it's using a DF33 battery valve, something really antique, 1.4 volt filament, and it has screw connectors either side. I thought it's great, no soldering, so what I need to do is swap round a couple of wires and we can use the Magic Eye. The whole radio looks like that, and yes, these are batteries. So this is a battery valve set running on batteries. There's the filament battery here. Obviously we won't be able to use this filament battery for the Magic Eye because it needs 6.3 volts, so we'll change that. But aside from that, this is what we'll be doing, and we'll see how well it works. Here we have it, one Magic Eye tube and nothing else. I've made a few modifications to the board here because there was a DF33 in it, but we've talked about that already, I know. So here we go. Quick listen to one of the broadcast bands and let's see how well this thing works. It's a bit touchy on the reaction, so you'll have to excuse it on that. I think that's the buzzer we can hear in the background. Let's see what we can find. See what I mean? It's a little bit touchy. Quite a few stations. I think that's a lot. So there you go. That is a Magic Eye radio. Just shows that things do work. It's surprising. It's not a very high gain valve, the triode part should I say, but it does work, I think, extremely well, all things considering. I'll pop up the circuit diagram of that if you want to actually have a try at making it. Yes, it's worthwhile. And the actual Magic Eye itself doesn't have to be particularly good. I mean, this one is very, very poor if we use it as a Magic Eye, but you can hardly see it. It's one of the ones I showed in my demo, which was really dark. Any questions, of course, ask down below. Thanks for watching.